Okay, so today we are starting. We're doing the reducing balance depreciation. I think up there is actually missing the word reducing, so we might put that in. So that should be reducing balance depreciation. And as it says there, it's an example of a geometric sequence, and we're going to look at a recurrence relation. So when you have decay and it's geometric, it means you're timesing by a number less than 1, yeah? Because that's how it will decay. All right, so we're going to see that in a minute. So the value of the asset gets smaller and smaller, and every time that the amount that it drops by will change as well. Because if you say you drop by 10%, so say for example, and you're going to drop geometrically, you would drop, say in the first year, 10% of it, say it was $100, you would drop $10. In the next year, you would be at 90. So what's 10% of 90? $9. So can you see the amount that it's dropping by is actually getting smaller and smaller. So that's where you see it's not the same amount, it's a percentage of the new total every time. So it decreases with value, and it's a changing amount. So just remember that it is a changing amount. Okay, not the same amount every time. All right, so we have got to work out a recurrence model for this. So like all the other ones, we'll have VO, and that will be the principal or the original value of the asset. Okay, and then we need our VN plus 1 rule. So the VN plus 1 rule will have that R. So the R is the amount that we're timesing. Now, because we're going to be decaying, that R is going to be less than 1, yeah? So the R will be less than 1. Okay, so how do we find out the R? So because the R, this is decaying, you're going to see this formula for R is going to be 1 minus, and we're going to say the rate over PPY. What does PPY mean again? How many times is it per year it's happening? And over 100. So you'll see a number less than 1. Of course, you're going to have less than 1 because it's 1 minus something. So you might just want to recap that R is the percentage rate per annum. So if we've got to change it to a monthly formula, it would be you've got to divide it by 12 and so on. And VN is just the value of asset after N periods. After N periods. Because if it was a monthly period and I said 2 years, N would equal 24. Yeah, because there's 24 months in 2 years, all right? So we need to be careful. And now, like all the other ones, we could do these slowly on our calculator, but that takes forever. So sometimes we're going to be asked to find the nth term there. So we need to get our formulas for the nth term. And for the nth term, we're going to have Vn equals, you'll use your R, whatever that's calculated to be, and then it's to the power of N times VO. Okay, so Vn equals the value of the asset after N periods. VO is the initial amount, and you need to remember obviously that you get your R by going 1 minus the rate over PPY over 100.
Is that capital R specific?
Yeah, it's a capital R, because little r, what do we use the little r?
Does the big one have a specific time?
No, it's just the timesing amount. The little r is the percentage rate per annum. It's because it's a rate. You're multiplying it by a rate, but it's a big rate that we're talking about. Okay, yeah, and so maybe just write that the little r, remember little r is percentage rate per annum. So I'm trying to help you out as much as possible with exam questions. They won't be like the textbook where it's always sort of per annum at the start. So we need to always be getting into the habit of fixing that. So essentially you could rewrite this formula. Instead of using R, you could write how you actually find R in the formula. So I could have it as 1 minus the R. And then you can say times VO. Yeah, so if you just wanted to go straight here, that's okay. It'll do it, you're doing everything there. All right, let's do these examples. So the following recurrence relation can be used to model the value of office furniture with a purchase price of $6,900. There's the VO at a reducing balance rate. So you need to highlight that because you're going to know you've got to go to those formulas and then they've told you 7% per annum. So that's your little R there. So can you see how they calculated this thing? Let's just write that so we know. It would have been the big R, which was 1 over, and if you do 7 divided by 1 over 100, you'll end up with 0.93. Okay, so that's how they found that. Okay, it says use the recurrence relation to find the value of the office furniture after 1, 2, or 3 years. So because we're just doing the start one, you can see there I put the 69,000 into the calc, press enter, and then what happens is we press times and we'll get that answer equals, and then you do it. So here's 1 year, 2 years, 3 years. So I've just written them out here. Now, can you see I'm rounding to, I round to 2 decimal places without being told. Why do I round to 2 decimal places?
Cents.
Yes, good. Because it's talking about cents, yeah? So that's rounding to cents, to nearest cent. And that's what we do, and that's what you should automatically do with money. Okay? So determine when the value of the investment will be first less than 5,000. So we're already up to 3 up here. Then we went 4 and 5 up there in the calculator. So it was so close, I just kept going. Didn't bother changing it round to the nth term. It was so close. So we're just going to say after 5 years, it made it. Okay, and now it says write down the recurrence relation if the furniture was initially valued at 7,500, so that's VO, and depreciating at, so once again, very important, reducing balance of 8.4% per annum, so that's my little R. So if I go off and write my recurrence formula, I need the VO. And the n+1 rule is going to be big R times Vn. So over here, I'm just going to work out what my big R is, which is 1 minus 8.4. They're not really saying yearly or what monthly, so I'm just going to pretend it's yearly. And we'll end up with an R value of 0.916. So I can write out this formula, this Vn plus 1 is actually 0.916 Vn. So remember that, and that is what we need in our answer for a recurrence relation. All right, okay, so the next one, a computer costs 9,500. So here's my VO. To buy, and decreases in value with the reducing balance depreciation. See how they're always going to be telling you, so you know what formula you need to use. And then it says at 20% each year. So that they gave you the little R. And when they said each year, that was their way of saying PPY equals 1. Yeah? And they also said it here because they said a recurrence relation that can be used to model the value of the computer system after n years. So they're showing you it's a yearly formula, was here. So just so you know, this bit here is the R, isn't it? That big R. That was big R, and the way they found it was they did 1 minus 20 over 1 over 100, and that got them 0.8. Okay, so write down the rule for the value after n years. So you can see here they're saying that this is a way of saying the nth rule. So we went to our formula sheet, we saw that it was that. Now you don't have to go calculate R because you could see that it was 0.8 up here. Yeah? So you just have to change it into the formula. So you can see it was 0.8 to the power of n there. So if you can't see that little power, times VO. What? So see, all I've done, here is Vn. I'm using this formula. R I can see was 0.8, so 0.8. Now the formula says to do the power of n, so do the power of n times VO, which I knew was 9,500. That's what I'm doing there. Okay, then it says use this rule to find the value of the computer system after 8 years to the nearest cent. So they were nice there. That means 2 decimal places. But this means we want V8. So you can see here in the notes, I put V8. Now, everywhere you see the letter N, you'll put an 8. That's why it's to the power of 8. So what we've actually calculated there, we've said V8 equals 0.8 to the power of 8 times 9,500, and we got this answer here. Now, it said to the nearest cent, so I've rounded that one up to 4. Okay? All right, so the next thing they asked me to do is calculate the depreciation of the computer. So what that just means is how much has the value dropped by? So if you look at the formula here, when you're trying to calculate the depreciation, you do the purchase price minus the current value. So really what you're doing there, you're saying VO minus what they're asking you, which is by 8 years. So VO was 9,500, and we calculated the value of V8 to be that, and then I simply subtracted it. So after 8 years, the computer has depreciated by this amount. So that's the amount it's dropped down by, yeah? You might want to write that down just in case so you know the wording. Okay, so with this next question, let's have a look. It says, an industrial weaving company purchased a new loom. A loom is like a big sewing machine, okay? And it costs $56,000. It has an estimated value of $15,000 after 10 years. What they have just told you there is like they've told you that V10, I'll just show you like that, V10 equals 15,000. That's what they've just told you, okay? If the value is depreciated using the reducing balance method. So now you know you've got a V10 formula and you know you're using the reducing balance formulas. Now the question here is what is the annual interest rate of depreciation? So they really want little r is the question. So you can see here I've gone to my formula sheet and I'm going to write this out again. So I've gone to my formula sheet and I've found the nth term formula. So I'll write that out. So Vn equals, and it's r times, r to the power of n times VO. So if I write out that, that's 1 minus r ppy over 100 times VO. Okay, now if I substitute this into the question I've got, I'm going to use V10. So that means I'm going to say 15,000. So I'm saying this is 10 equals 1 minus R. That's what I want to know. And now it's only yearly, so 1 over a year, times 100. Sorry, forgot to the power of n. So this one is to the power of 10 times VO, which was 56,000. So that's what I've gone and put in the calculator. So can you see how I've done, I've done solve, pop that in, and comma R. So when you do that, you're going to find you get two answers. So can you see down here when I do it in the calculator, and I'll do it in a minute on the actual calculator, you see that you get these two answers. Is the rate's not going to be a number over 100, is it? No. So you take the smaller one, which is 12.34. They said to 1 decimal place, hence why this answer is 12.3. I'm going to show you this on the calculator so you can see what I'm talking about. All right, so I put an exam question in here, so let's have a look at this. So the purchase price of a car was 26,000. So if we're trotting along here, we know that's VO. The reducing balance method, using the reducing balance method, so we know that's the formulas we'll be using. The car depreciates at 8% each year. So you just got told little r is 8%. And now they're asking the recurrence relation that can be used to determine the value of this car after n years is. So they've just told you that to make sure you know you're doing a yearly formula. So really that's clearing up that PPY is 1. All right, now if you're quick, we've got to try and be quick about answering questions if we can. So we've quickly looked at the VO, they're all the same. There's nothing different there. The next thing I know is reducing balance, it should be timesing by a number less than 1, shouldn't it? Yeah? So can you see, I'm going to go, no, that one's out, it's more than 1. That one's adding, that one's subtracting something. This is doing everything but just timesing. So here's my answer, A. Can you see I did not go through all that hoo-ha of substituting, did I? Do you think that was a little bit quicker than working it all out using your maths? So that's what you got to do. You got to sometimes tackle a multiple choice like that. It gains you time. So boys, we're just going to go over the last bit. If they say a nominal interest rate, that's the interest rate per year, yeah? So when we say 8% per annum, that is the nominal interest rate. If we change our formula to a monthly formula, that rate is a different rate. It's not known as the nominal. So when they refer to the nominal, they're giving you, it's like they're giving you the per annum one. So that's why we've put that there. The nominal is the per annum one. All right, so just to make sure that you are clear, when you are changing it to down here, if you're writing a monthly formula, you are going to do the compounding interest rate. It's going to be the rate per annum divided by 12, isn't it? So in here, sorry, I think there wasn't enough room left. It should be 1 plus the rate divided by what? If it's monthly, it'll be 12 over 100 to the power of n times VO. Okay, so if it is weekly, so this was, I'm just going to write in brackets, monthly, there. If it was weekly, it'd be Vn equals 1 plus the interest rate per annum divided by how many weeks in a year? 52 over 100 to the power of n times VO. So weekly will be the per annum rate divided by 52. What will the fortnight one be? Right, the rate divided by fortnightly, 26. Daily, they will tell you to ignore that it's a leap year. So how many days in the year? 365. And quarterly, what would that be? The rate divided by 4. So I'll just do this last one. So the quarterly one, so this was weekly. the quarterly one will be, this is compound interest. So 1 plus the rate divided by 4 over 100. If it is reducing balance, it'll be 1 minus, won't it? Yeah? Just be careful with that. So this R, when they quote this little R here, that is the nominal interest rate that they're giving you. It's known as the nominal. Okay, so an investment account will pay interest of a rate of 3.6 per annum. It says convert these rates to a monthly rate. So what I've done there is I've taken 3.6 and I've divided it by 12 and I got 0.3%. When I said fortnightly, I took 3.6, I divided it by 26 and I got 0.138%. When I did quarterly, I took 3.6, I divided by 4, and that's how I got 0.9%. Okay? All right, so you're going to do the rest of the exercise 8E and 8F today, which is 5 to 6 on the E and 6 to 13 on the F, because you did the beginning of those last lesson.